Welcome to the Explainer. So, every single day, we're staring at our screens, right? We're sending just massive amounts of data all over the globe in literal milliseconds. And honestly, we'd basically treat it like magic. You tap a piece of glass, and boom, a video from halfway across the planet starts playing. But how often do we actually stop to think about the physical architecture making that whole seamless experience possible? Today, we're going to decode the physical and the logical reality behind how we all get online. We're breaking down these complex, invisible systems into clear, structured concepts. So, get ready to look at your digital life in a totally new way.
Okay, let's dive into this by immediately busting one of the biggest myths in modern tech. Just take a second and think about this. Are you using the internet or are you using the World Wide Web right now? If you answered both, or if you're thinking, wait, those are the exact same thing, you are absolutely not alone. Most of us use those terms interchangeably every single day. But functionally, technically, and even historically, they are completely different entities. And honestly, understanding this difference is the absolute foundation for understanding our entire digital world.
So, let's look at them side by side. First up, the internet. This is the underlying massive physical and logical network infrastructure that links devices globally. It runs on core protocols, which are basically just sets of rules, like IP and TCP. You can kind of think of IP and TCP as the fundamental traffic laws dictating exactly how your data gets from point A to point B. It's the raw foundation. Then you have the World Wide Web. The web is really just a system of interlinked hypertext resources. Essentially, it's just one specific service running on top of the internet, using its own protocols, like HTTP and HTML. So if IP and TCP are the traffic laws, HTTP and HTML are the languages used to, paint the billboards and build the storefronts along those roads. When you're playing an online multiplayer game or sending an email, you're using the internet, sure, but you aren't necessarily using the web.
Actually, there's a brilliant quote that perfectly illustrates this. The internet is the road system. The web is the delivery service. Think of the internet as the global road system itself. The physical asphalts, the interconnected highways, the bridges linking cities together. The World Wide Web? That's simply a delivery service using those roads to bring you information. The web is basically the fleet of trucks delivering web pages straight to your browser. And what's really fascinating here is that those trucks literally wouldn't be able to move an inch without the internet's road system already beneath them. When Tim Berners-Lee proposed the World Wide Web at CERN back in 1989, he wasn't trying to invent the whole modern digital universe. He really just wanted a better, more efficient filing system so scientists could share documents across the existing network roads. Let's move to the timeline and see how this all builds up over time. We actually have to travel way back to the 1960s and 70s with ARPANET. This early network proved a revolutionary concept called packet switching. See, instead of sending a file as one giant, clunky chunk, packet switching breaks data down into tiny little pieces or packets. This meant that if one digital road failed or got totally jammed up, the packets could just automatically take an alternate route and then reassemble at the destination. It was a completely vital design choice for building a robust network. Then, we get a massive leap in 1983 with the introduction of the domain name system, or DNS. Computers, they communicate using numeric IP addresses, which, let's face it, are incredibly hard for human beings to remember. DNS acts as the ultimate digital phone book, translating those complex numbers into human-readable names. It is literally the only reason you can type example.com instead of a long string of random digits. And that paved the way for Berners-Lee's web in '89 and the graphical browsers of the 1990s that finally opened cyberspace to the public.
Now, moving into the modern era, the pace of change becomes absolutely breathtaking. The 2000s brought us Web 2.0 and, of course, the massive rise of social media. This was a total paradigm shift because it turned everyday users from passive readers into active content creators and publishers. Then the 2010s saw everything move to the cloud, connecting billions of smart devices through the Internet of Things, or IoT. Suddenly we had billions of devices, from smart thermostats to cars, just talking to each other behind our backs. And here we are in the 2020s, entering the era of Web 4.0. We're looking at massive AI-assisted services, 5G speeds, and edge computing. That means processing data right where it's created, like directly on your smart fridge, instead of sending it miles away to some distant server. But with this incredible personalized automation comes a huge increase in cybersecurity risks that we have to manage every single day. Okay, so we've talked a lot about the conceptual history of cyberspace, the software, and the protocols that dictate how data moves. But information isn't magic. It doesn't just, float through the ether. It is highly physical. To truly understand our digital world, we need to completely shift our perspective. We need to transition from the conceptual history of these roads directly into the gritty, tangible, physical reality of them. We're going to look at how your data actually travels across the planet to that device sitting in your hands right now.
Now, what's really interesting about this slide is seeing how your digital life is actually this delicate, high-speed relay race relying on four main physical communication technologies. Like, you might start streaming a video on your high-speed Wi-Fi at home, right? Which gives you incredible flexibility, but it does open you up to local eavesdropping. Then, as you walk outside, your phone seamlessly hands that data off to a 5G mobile tower. That gives you high-speed mobility, though it comes with its own risks like SIM fraud. Now, if you're on a remote ship or an aircraft, your data might bounce off satellite technology. Unmatched remote coverage for sure, but it really struggles with weather interference and latency delays. And connecting all of these local hubs together, fiber optic technology. Fiber gives us massive, just unimaginable bandwidths, but it comes with a major physical vulnerability. Those cables can literally be cracked. So the crucial point here brings us to a frankly mind-blowing realization. The cloud? It's kind of a bit of a lie. We always talk about our data living in the cloud, up in the sky, safely floating above us. But the reality is quite the opposite. According to Teleography's map for 2025, 597 is the number of massive submarine cable systems currently active or under construction globally. The vast majority of our global internet traffic does not go through the air. It travels as pulses of light through fiber optic cables resting right on the bottom of the ocean floor. And honestly, here's the craziest part. Many of these deep-sea cables, carrying terabits of data per second across entire oceans, are often no thicker than a standard garden hose. And those 597 underwater cable systems, they connect across exactly 1,712 global landing points where they finally come ashore. Just think about the fragility of that for a second. The entirely wireless, digital, invisible world you experience on your smartphone relies fundamentally on a highly protected yet vulnerable underwater reality. Historically, this physical infrastructure has faced some really bizarre physical threats. We're talking a single commercial ship dropping an anchor in the wrong spot, an underwater landslide, or, no joke, even sharks biting the cables. These things have literally caused entire countries to experience massive internet blackouts. And when that happens, the logical layer of the internet, remember those TCP and IP traffic laws we discussed earlier, it has to instantly kick in and reroute your data through a completely different physical path, just so your video keeps playing without a hitch. So we've gone from the ARPANET experiments of the 1960s to an incredibly robust web of protocols, all the way to thousands of garden hose-sized underwater cables and AI-assisted networks today. As we push even further into the era of Web 4.0, integrating advanced artificial intelligence and billions more connected devices, what will the next road look like? And perhaps more importantly, how are we going to secure this fragile, highly physical relay race? Thank you so much for joining me for this explainer. I really hope this structured look at our digital infrastructure has empowered you with a much deeper understanding of the tech you rely on every day. So next time you tap a link, remember the invisible trucks, the global highways, and those underwater cables making the whole shebang happen. Keep learning and stay curious.